Hello, I'm Hao Li from Nanjing University of Science and Technology. I'm very pleased to introduce our recent work published in ICCV2025, FoundIR, Unleashing Million-Scale Training Data to Advance Foundation Models for Image Restoration. Image restoration aims to recover a high-quality image from a degraded one. The degradation can come from many real-world factors, such as blur, noise, haze, rain, or low light. In this paper, we first conduct a detailed analysis of how synthetic and real-world datasets affect the performance of universal image restoration. The green line indicates that models trained on synthetic data perform poorly in real-world scenarios, as the domain gap limits the performance. In contrast, the blue line shows that incorporating existing real-world data leads to a significant performance improvement, though the limited amount of real data still constrains the upper bound of performance. Therefore, it is urgent to build a large-scale, high-quality training data pool to facilitate the advancement of real-world universal image restoration. We can summarize our main contributions as follows. We construct a million-scale, high-quality paired training data source. We introduce FoundIR, a robust high-capacity restoration model that adapts to various degradations and generalizes well across diverse real-world scenarios. And we demonstrate the value of the proposed dataset and the effectiveness of our FoundIR. To collect large-scale, high-resolution image pairs, we elaborately build a mechatronic shooting system consisting of an electric slide rail and two same tripods. Our data collection can be divided into 3 stages. 1. Capturing GT data. 2. Capturing LQ data with internal camera settings. 3. Capturing LQ data with external imaging conditions. After capturing the data, we select aligned GT-LQ frames from the uniform moving phase in a frame-wise manner. The proposed dataset offers 2 notable advantages over existing universal image restoration datasets: larger-scale real-world samples and higher diversity data types. In total, the training and testing sets of our proposed dataset contain 1,011,614 and 1,500 paired images, respectively, covering 20 types of degradation. Here are some samples of our proposed dataset. To better deal with complex and diverse degradations in real-world scenarios, we propose FoundIR, a robust image restoration model trained on our million-scale dataset. We incorporate one generalist model and multiple specialist models into ensemble framework. Specifically, in our generalist model, we utilize a residual diffusion model to efficiently decouple complex degradation information. We introduce condition constraints beta on the degraded input to prevent the model from collapsing into dependence on a specific degradation. We further introduce several specialist models to refine the partial restoration capability in complex scenarios by considering the characteristics of degradation-aware information. To alleviate the issue of catastrophic forgetting, we adopt the incremental learning strategy to facilitate better model convergence. Specifically, we first establish a task incremental pool, gradually adding data streams from different tasks to prevent interference and competition among multiple tasks during the early model's learning phase. In this way, a well-trained model on isolated degradation class can provide a solid starting point for training on coupled degradation class. We evaluate our method on the proposed dataset and several real-world benchmarks. Table 1 shows the quantitative comparisons with SOTA methods on the proposed benchmark, where our FoundIR achieves the best performance across a broad range of image degradation types, including both isolated and coupled degradations. Table 2 shows that our FoundIR achieves the best restoration performance across all public real-world benchmarks, indicating its capability to generalize well to out-of-distribution data. For qualitative comparisons, our FoundIR generates better results, e.g., the clear characters and few artifacts, for both isolated and coupled degradation inputs. Thank you for your listening. You can find our paper and project in the following.